Amid widespread anticipation from millions dreaming of owning an Optimus and believing it would take care of daily mundane tasks or be used as part of a 2.0 workforce in Tesla's factories, Elon Musk dropped a bombshell. Optimus will initially be sold only in the United States. More precisely, Tesla will focus on the domestic market first. So why is this happening? How will Tesla sell the Tesla Optimus? Before we begin, please help us reach 6,000 subscribers. It will be a huge motivation for us to continue bringing you great episodes about Tesla Optimus and the latest news. During the all-hands meeting, aside from questions regarding the development process of the humanoid robot Optimus, an investor asked about Optimus's supply chain. This was an important question because Elon Musk had announced last month that the Tesla bot production line would be rapidly accelerated, with 5,000 units being the most optimistic target for 2025. And that is exactly why Elon Musk is developing the Tesla bot. If successful and entering mass production next year, it could mark a major turning point, not only in technology, but also in the way we live and work.
Optimus was affected, by the magnet issue from China, because the Optimus actuators in the arm do use permanent magnets. Now, Tesla as a whole does not need to use permanent magnets, but when something is volume constrained, like an arm of the robot, then you want to try to make the motors as small as possible.
However, it seems that even Elon Musk did not anticipate a major obstacle impacting Optimus. A crucial component vital to the robot's functionality is heavily reliant on China. Specifically, China's tightening of rare earth exports is directly affecting the Tesla bot Optimus, making it difficult to secure a stable supply of essential parts like the permanent magnets used in the robot's arm actuators. Although Tesla is currently working with the Chinese government to obtain export permits, this situation has clearly slowed down production and driven costs significantly higher than originally expected. Against the backdrop of supply chain threats and ongoing U.S.-China trade tensions showing no signs of easing, Elon Musk's decision to initially focus Optimus sales within the United States becomes more understandable. This move is not only aimed at minimizing risks stemming from China's export policies, but also serves to maintain tighter control over production and distribution, especially important as Optimus continues to evolve through newer generations. How does the cost of owning a Tesla bot under the impact of USTAX?
You also need to be very good at scale manufacturing. So in order to have the robot not cost like hundreds of thousands of dollars, in order to make it cost like $10,000 or $20,000.
Tesla's Optimus Gen 3 humanoid robot is not the risky gamble some might believe it to be. From day one, the project has smartly leveraged the world's most experienced EV supply chain, combined with an AI platform operating across more than 5 million vehicles and thriving within a culture that embraces solving challenges in the public eye. Although new rare earth export regulations have undoubtedly driven up component costs, particularly for magnets, Tesla has previously turned battery supply bottlenecks into an advantage that propelled the Model Y to the top of the market. Now the company is applying a similar strategy to magnets. Elon Musk's promise of around $20,000 once we achieve high-volume production still holds true, as he was referring to a downward price curve rather than a fixed single figure. A humanoid robot featuring a 22 degree of freedom hand design, priced under $20,000, and with a production target of millions of units before 2030. These are such staggering figures that Wall Street is holding its breath as Elon Musk prepares to respond to the latest tax battle. What initially appeared to be a simple complaint about tax has, in fact, revealed itself as a moment when Tesla quietly fine-tuned the Optimus Gen 3. A more streamlined controller, an accelerated production timeline cut down to 1/3, and a reduced price tag below $20,000. Elon Musk also emphasized during a recent meeting that Tesla now has a higher level of localization than any other manufacturer and plans to strengthen this even further in the future. However, this is not necessarily good news for customers outside of North America who are eagerly awaiting Optimus, as the robot may not only be more expensive but also significantly harder to purchase. Governments might even impose taxes on it given its immense potential to benefit humans. Unlike Tesla's electric cars, which often sit idle in parking lots for most of the day, the Optimus robot is designed to actively work, handling tasks for you and even potentially generating income by performing jobs on your behalf. Tesla's response to rising tariffs on electronic components and rare earth materials was to aggressively push toward vertical integration, and by the first quarter of 2025, that strategy had significantly reshaped the Optimus Gen 3 program. Currently, 72% of the robot's components are sourced from suppliers in North America, a sharp increase from just 45% a year earlier. The rapid expansion of new production lines in Texas and northern Mexico has brought electric motor, gearbox, and battery pack manufacturing in-house, cutting the average cost per robot by 18% and enabling the company to pursue its ambitious retail price target of $15,000. All while tightening control over its supply chain. Tesla invested $2.4 billion into Optimus-related infrastructure during the first quarter of 2025 and expects to recoup that investment within 3 years, driven by the growing global demand for service robots. Hundreds of Optimus units are already operating inside Tesla's gigafactories, handling material transport, inventory tasks, and routine machine maintenance, efforts that have helped lower factory operating costs by 17%. Musk argues that such a broad range of applications will fundamentally change the way we think about labor, companionship, and exploration, positioning Optimus as a multiplier of human potential. Tesla's internal forecasts, supported by its newly self-sufficient supply chain, project a production capacity of 100,000 units per year by 2026. By actively combining vertical integration with targeted pilot deployments, Tesla has shielded Optimus from tariff shocks, accelerated the production process, and paved a reliable path for the robot from factory prototype to daily companion. Tesla's move toward vertical integration has also fostered greater design flexibility and technological innovation within the Optimus Gen 3 program. By consolidating key manufacturing processes internally, Tesla's engineering teams can iterate faster on hardware and software upgrades, tailoring components to work seamlessly with the robot's neural network and motion control systems. This tight integration between design and manufacturing has reduced dependency on third-party timelines, minimized component incompatibility, and created a more unified development cycle, giving Tesla a distinct competitive edge in a rapidly evolving robotics market. Moreover, the increased localization of component sourcing has enabled the company to better navigate geopolitical uncertainties and environmental regulations. By reducing reliance on overseas shipments and volatile international suppliers, Tesla not only lowers logistical risks, but also reduces the carbon footprint of each unit produced. A key consideration as environmental sustainability becomes central to both consumer choice and regulatory frameworks. In effect, vertical integration is not just a cost-saving tactic for Tesla. It has become a strategic enabler for rapid innovation, supply chain resilience, and long-term scalability, all essential pillars as Optimus moves from industrial support roles to more personalized applications across homes, hospitals, and public infrastructure. Why are the new hands of Tesla Optimus considered a masterpiece? What are Tesla's plans for the Tesla Bot Gen 3? That's what we'll dive into in today's episode. Welcome to Techno Creators. Before we begin, please help us reach 5,000 subscribers. It will be a huge motivation for us to continue bringing you great tech episodes. In the new image shared by the Tesla Optimus team on X, this is the first time we've seen Optimus in an all-black design since the debut of Gen 2. Based on our search using the Grok AI platform, this variant of Optimus appears to be designed for a Mars mission, announced by Elon Musk in March 2025. Unlike Gen 2, which was built for Earth-based tasks such as factory work, this version features a helmet and visor for space travel, providing protection against the harsh conditions of Mars. For years, Tesla has demonstrated rapid progress in improving the flexibility of robot hands. It seems the company began by researching and developing the initial hand design and launched the Tesla Bot with 11 degrees of freedom. In just 4 years, that number has doubled to 22 degrees of freedom, according to Elon Musk. Although the two joint fingers do not yet closely mimic the human hand, the robot has already been able to perform most tasks, including those in factories and daily human life. Since the Optimus project was announced, Elon Musk has made it clear that Tesla has no intention of following the storyline of I, Robot, Terminator, or any other fear-inducing sci-fi film where humanoid robots turn against humanity. Instead, Musk is confident that the Tesla bot will be more like C-3PO or R2-D2 from Star Wars, designed to assist humans with difficult, repetitive, and mundane tasks. The new black design, or any other color for that matter, doesn't truly define its nature. In fact, Tesla has previously showcased a bronze-colored Optimus. This clearly suggests that Tesla Optimus will likely come in various color options, or possibly in 3 different variants designed for different purposes. Optimus Gen 3 is likely to be redesigned to strike a balance between aesthetics, cost, and mass production capability. That doesn't mean it will look cheaper, quite the opposite. It will likely adopt the same approach Tesla uses with its electric vehicles. Take the refreshed Model Y, for example. It's been redesigned to be better and more efficient without increasing production costs. When Elon Musk said that the Tesla bot would eventually be sold for around $20,000, most of us assumed that was the price for the entire Optimus robot, but that's not entirely the case. Tesla bot will likely come in 3 versions. The white Optimus Gen 3 variant, priced the lowest, will be widely used and sold on the market. It will be capable of performing repetitive tasks in factories and confidently handling human healthcare tasks at home. A bronze-colored version is likely a more premium variant aimed at a higher-end market. Although it may not differ much in design, it resembles Tesla's approach with its vehicle lineup. Upgraded performance without drastically changing the look. The same likely applies to this Optimus version. It may come equipped with a completely different battery pack, possibly still using 4,680 cells, but with higher performance or even more advanced solid-state battery technology. Finally, a fully black version is likely the most advanced variant, though it may not be a commercial product. Tesla already has concrete plans for 2026, confidently stating that Optimus will take part in its Mars exploration mission. This fully black version is equipped with additional solar panels around its body, enabling the Tesla bot to extend its independent operating time without needing to recharge at a station. Additionally, from our perspective, if the Tesla Bot Gen 3 can do everything a human can and operate for at least 10 hours a day with minimal maintenance, then a $50,000 price tag actually sounds quite reasonable. When you consider the average price of a typical humanoid robot today, it usually ranges from $100,000 to over $150,000. That's why, for decades, no company has confidently claimed they could mass-produce humanoid robots at scale. But Tesla is different. Their production costs tend to decrease over time. So we believe that as production scales up, the cost of all Optimus variants will become much more accessible. For the 2 commercial variants, there may be a few key differences to note. The more premium Tesla bot variant could be equipped with hands that feature 3 jointed fingers, significantly increasing the degrees of freedom. This version might also allow the robot to access the full suite of full self-driving capabilities. This is entirely plausible, considering how Tesla handles its electric vehicles. For example, the full self-driving option gives users access to the complete autonomous driving program, but it comes at a cost of $8,000 when selected on the Tesla website for the Model Y Juniper.
So, ultimately, I think we'll be making tens of millions of robots a year type of thing. It's like serious volume. Maybe 100 million robots a year.
Tesla could eventually produce tens of millions, or even hundreds of millions, of Optimus robots per year. That would mean manufacturing at an absolutely insane pace. But that's a long-term goal. A more realistic milestone for now would be around 1 million Optimus units per year. Tesla, we will need a highly automated assembly line where every component, from batteries and actuators to sensors and the robot's frame, is assembled with incredible speed and precision.
And Tesla has some important missing ingredients that others don't have, which is our robot has a real brain. It's like the Wizard of Oz, Tin Man.
When Elon Musk talks about the Tesla bot having a real brain, he's referring to an extremely sharp information processing system, one that could potentially surpass humans in understanding and reacting to the world around it. It sounds crazy, and you wouldn't even need to give it a command. That's exactly what Musk envisions. A brain intelligent enough to read the situation, understand the environment, and act accordingly. However, for the most affordable version, rumored to be priced under $20,000, it is speculated that it could be used as a remotely operated product. This would be based on VR control systems and supporting control devices, combined with an AI capable of operating at about 50% automation. You might be surprised to learn that silicon can store lithium 24 times better than graphite, which is why Tesla has added silicon particles to the anode to significantly increase range performance by 20%. Building on this proven achievement, a new generation of battery technology uses fully silicon anodes made from silicon nanowires, promising sustainability and absolute safety. What improvements have been made in silicon battery technology? What innovations have been made in nanowire silicon anode batteries? When researchers first began exploring silicon as a positive electrode for lithium batteries, Tesla also enhanced lithium retention at the positive electrode by adding a small amount of about 5% silicon. This factor has helped Tesla significantly reduce the production cost for each battery cell containing silicon at the positive electrode to $1.20 per kilowatt hour, surpassing the capabilities of current batteries used in electric vehicles. The high-performance battery developed by Amprius, a company specializing in revolutionary silicon anode batteries, boasts double the energy density of the 4680 cell, achieving 500 watt-hour per kilogram compared to 450 watt-hours per kilogram in the older silicon anode version. This game-changing factor could extend the range of the Tesla Model 3 to about 400 miles. With a single silicon atom, it can store 4 lithium ions, meaning that silicon anodes are 24 times more efficient than conventional lead anodes. It also allows silicon anode batteries to have a capacity of 3,400 mAh per gram, nearly 10 times higher than conventional lithium batteries with lead anodes, which have a capacity of 355 mAh per gram. The motivation behind silicon anode batteries is largely driven by their ability to store more energy than conventional lithium-ion batteries of the same weight and volume. However, their increased energy density may also introduce new, distinct risks that could be more dangerous in the event of a failure. Although this technology has been researched and developed by the company for a long time, the issues of silicon swelling during lithium-ion storage have rapidly reduced the lifespan of the batteries. This has driven the manufacturer to explore the development of silicon nanowires. A simple explanation of this technology is that these nanowires are grown within the battery cells at specific distances. As they receive ions transported from the cathode, they increase in size up to a maximum limit. However, they will only grow to a certain size without exceeding permissible limits, similar to how tree canopies expand over time. But the spacing between the trees is determined to prevent the canopies from feeling cramped. Furthermore, this improvement facilitates the transport of ions and electrons over shorter distances, making charging faster compared to traditional graphite anodes, with the manufacturer claiming a fast charging capability of 80% in less than 6 minutes. This is truly a breakthrough in charging, as most of the slowdown in the current electric vehicle trend is due to users' concerns about convenience and speed, similar to filling up a gas tank for internal combustion vehicles in just 1 to 2 minutes. Considering the importance of this not only for electric vehicles but also for all types of energy storage applications, this is indeed a transformative technology. Silicon nanowires offer several advantages over conventional silicon particles used in current battery technologies. First, the nanowire structure not only provides a large surface area, optimizing the absorption of ions from the cathode, but also maximizes the space for electrochemical processes to occur efficiently, ensuring high performance and longevity of the battery. This is a breakthrough in battery technology, promising significant advancements in the automotive and energy storage industries. Second, they exhibit flexibility, capable of bending or stretching without breaking away from the surface. This feature helps prevent the formation of cracks, similar to issues encountered with silicon particles and positive electrodes, which can reduce the efficiency and safety of the battery. As a result, they have addressed the drawbacks of this silicon anode technology with the goal of applying it to electric vehicle and aerospace technologies in the future. Additionally, the materials proposed in this next-generation technology are neither expensive nor difficult to produce. They are the second most abundant component on Earth. This helps reduce battery costs and ensures that there will be no supply chain issues in the future. Statistically, over 90% of the world's graphite comes from the Chinese market, and furthermore, the graphite smell generates toxic emissions that are 10 times greater than what we think. However, the production of silicon anode technology requires specialized equipment and techniques due to the creation of silicon nanowires. To achieve greatness in applications for electric vehicles, Amprius has partnered with companies specializing in the production of silicon nanowires to address the barriers in the manufacturing process, helping to reduce the costs associated with this process. What is the superior heat resistance of silicon anode batteries? Amprius's next-generation battery technology has been tested through impact and penetration tests according to military performance specifications to assess the feasibility of a specific product in combat situations. It passed the test without any smoke or fire effects. When measured with an infrared thermometer, the temperature of the battery cell only increased by 0 to 10 degrees Celsius around the area where the sharp object penetrated. This demonstrates the puncture and fire resistance of the battery when applied to electric vehicles. In contrast, lithium graphite batteries have undergone several tests, resulting in ignition immediately upon impact with sharp objects. Furthermore, the company has made a new claim about its ability to operate effectively in environments as cold as -30 degrees Celsius and up to a maximum of 55 degrees Celsius, with results indicating that the battery's performance is not affected by temperature factors. This resilience not only enhances the safety and reliability of electric vehicles, but also broadens their usability in various climates, making them more appealing to a wider range of consumers and industries. As Amprius continues to innovate, their advancements may set new standards in the battery technology sector, paving the way for safer, more efficient energy storage solutions. Why could silicon anode batteries transform the entire EV market in the US? Previously, silicon transformed how we store information, and now it is changing how we store energy. It promises to produce electric vehicles with longer ranges, faster charging, and more affordability compared to those using conventional lead-based anodes in current batteries. Most commercial battery manufacturers view silicon nanomaterials as a solution to issues such as swelling and side reactions. However, the production of nanomaterial-based batteries can be expensive, and their manufacturing requires specialized anode technology that is incompatible with existing large-scale EV battery manufacturing plants. Although Amprius's batteries have performed well in both laboratory and real-world tests, scaling up nanotechnology from the lab to real-world applications can be a challenge, as previously noted. There's much work to be done in the United States to help us lead in the next generation of energy technology. That is why Amprius is currently focusing on suitable applications such as urban air transport. This allows them to demonstrate battery performance while addressing current capacity limitations. Now, with scaling up, they have the potential to penetrate other market applications like electric vehicles. At their Fremont facility, Amprius has built a pilot plant with a production capacity of hundreds of kilowatt-hours per year. Additionally, electric vehicle manufacturers smaller battery packs to achieve a range of 400 miles with silicon batteries. This will help reduce long-term costs and make the vehicles lighter, especially with the extensive charging network that Tesla has installed throughout the streets of the United States. Essentially, the shift to silicon anode technology not only enhances the performance and safety of batteries, but also aligns with environmentally conscious practices by environmental impact associated with lead battery production. With this new move, Amprius's silicon battery is set to be mass-produced at a new factory in Colorado, which will be operational in 2025 with a capacity of 500 megawatt-hours, with the potential to expand up to 5 gigawatt-hours. This plan will significantly increase Amprius's production capacity and meet the strong demand for high-performance silicon anode lithium-ion batteries in the United States EV market. How disruptive would the electric vehicle industry battery technology breakthrough were achieved? Share your opinion in the comment. What makes the Tesla Model 2 Redwood only $25,000? First, the Redwood uses LFP batteries, which reduce manufacturing costs compared to nickel aluminum oxide or nickel cobalt manganese oxide batteries. The total raw material cost for LFP batteries is typically 40% lower than NCA, largely due to the of iron and phosphate compared to nickel and cobalt. The raw material cost for NCM and NCA batteries is significantly higher due to the need for precious metals, such as cobalt and nickel. This can result in a reduction in battery manufacturing costs per vehicle, ranging from a few thousand to tens of thousands of dollars, depending on the size and version of the vehicle. LFP battery manufacturing technology is typically simpler, which also reduces manufacturing costs by 10 to 20% and complex processing steps than NCA or NCM batteries. LFP batteries have a longer life and better heat resistance than NCA, reducing the insurance costs Tesla must cover under warranty. LFP are considered environmentally friendly due to the use of available materials and less precious metals, saving about $300. LFP batteries can be considered the most useful and reasonable solution to incorporate 2025. It helps reduce the total cost of production, reduce the total cost of redwood, bringing an effective approach from the customer side. Second, Model 2. Redwood has a simple and effective design, which is said to be small models such as Model Y and 3, helping to reduce production and material costs. Effective when operating in crowded urban areas and parking areas with limited space. Despite its smaller size, the Model 2 Redwood is said to carry the spirit of the Model 3 and Y but still achieve high performance and driving feel, allowing enthusiasts to still own it, but at a cheaper price. The minimalist interior has a 15-inch control screen in the center of the using artificial leather materials and a large luggage space with a capacity of 300 liters. The Redwood has a simpler, more sustainable interior design but still ensures basic comfort. Third, Tesla takes advantage of tax incentives for electric vehicles to make the Model 2 Redwood attractive and competitive in the market. The company designs vehicle standards, tracks the amount of federal tax credits used for its models to optimize the timing of release, and maintains the benefit of the federal tax credit of $1,500. It also takes advantage of state and local incentives, such as tax breaks, parking incentives, to expand its market. Tesla also takes advantage of government policy to expand its supercharger network and incentivize the installation of home charging stations, which earns customers $1,000 for installing. Tesla not only makes the Model 2 Redwood more accessible, but also attracts more potential customers. Finally, Tesla uses a cost reduction strategy, which plays an important role in affordable. Tesla plans to expand the market and create opportunities for more consumers while increasing competition with competitors in the same segment. Assuming that 65 people in the world are interested in this brand, Tesla priced Redwood to increase brand awareness. 80% of people worldwide. Tesla uses a less expensive communication strategy than mainly relying on launch events, word of mouth, or social media to attract. What will motivate Tesla to a battery technology for Tesla bus? The journey of Tesla's electric bus has garnered attention and sparked much speculation since he announced the ambition in Tesla's Master Plan Part 2 in 2016. In this document, Musk emphasized the crucial role of electric power not just for personal vehicles, but also for heavy trucks and public transportation systems in densely populated urban areas. With the company's commitment to environmental protection and reducing emissions, the Tesla Mega project, with a capacity of megawatts, is designed to provide electricity for electric bus depots and is supplemented by solar panels for an independent power grid, showcasing Tesla's dedication to sustainable energy solutions. The advantages of electric buses are clear. They help reduce air pollution, operate more quietly, and save costs due to lower electricity prices compared to fuel. In comparison, the operating costs of electric buses can be up to 40% lower than diesel buses. Coupled with CATL's new battery technology, which is promising and cost-effective ability of raw materials from China, the estimated price for the Tesla bus is $120,000. Depending on size and configuration, this price may vary, but it remains 10 times cheaper than the collapse of Proterra and 40% cheaper than the electric buses currently operated by BYD, which start at $180,000. The development of the Tesla is not only a significant advancement in the transportation sector, but also reflects the company's broader vision for a sustainable future. These efforts not only help improve air quality and reduce costs for cities, but also lay the groundwork for a more modern and efficient public transportation system. As Tesla continues to innovate and expand, there's hope that these solutions will become the new standard in the transportation industry, making a positive contribution to the fight against climate change. What do you think about this? Feel free to share your thoughts in the comments section below. We hope to bring the best information to you. Please give a thumbs up if you like this, Join Techno Creator by subscribing and hit the bell icon so you will not miss out on any awesome videos. We value your feedback. Thanks for watching. Until then, stay safe.